These are examples of adding and subtracting polynomials from Delta Math. The key here is to combine like terms. So remember, like terms have to have the same variable and the same exponent to be able to combine. So you have two polynomials here. Both of them are trinomials because they have 1, 2, 3 terms each. 1, 2, 3 there as well. The first problem, both of these have the instruction that just says perform the operation. In order to know which operation to perform, you want to check right here in the middle of parentheses. So on the first one, we see addition. On the second one, we see subtraction. And subtraction will work a little bit differently than addition. For addition, our first step is to just remove those parentheses. They aren't really necessary because the only number that's happening right here in front of the second set of parentheses is 1. Same thing out here. There's just an implied 1 there, and that doesn't change anything, even if we were to distribute it. So pretty much what happens is we're going to bring everything straight down. We're not changing anything. We're just getting rid of those parentheses. So now it comes down to combining like terms. If you have different colors, it can help you identify those like terms first before you start combining. If not, you can use different styles of lines. You can circle your terms, put a square, triangle, cloud, whatever you see fit. So I'm looking for other terms with an x squared. Looks like I have one here, and I'm going to make sure to underline the sign as well, include the sign. All right, when it comes to the x's, looks like I have a negative 10x, which will eventually pair with a negative 5x. The sign in front of each term is important. It's going to tell you what to do to combine your terms. Okay, so now that all my terms are identified, I'm going to go ahead and start combining them. So the first one says 3x squared plus 10x squared. That should make 13x squared. From the blue terms, we have negative 10x minus another 5x to make negative 15x. And last but not least, we have a positive 4 plus another 8, which should make positive 12. I don't have any more like terms, so that makes my final answer. Now subtraction is nearly the same. The only difference is because we have a minus sign in the middle, it's like we have a negative 1 happening in front of this set of parentheses. So what's going to happen first is I'm going to use the distributive property and multiply each of the terms in the second set by negative 1. That'll make sure that I actually technically subtract all of those pieces and not just the first one. So I'm going to drop the first set of parentheses and just bring all of that stuff straight down. Then I'm going to multiply. So I have negative 1 times negative 7 makes positive 7x squared. Negative 1 times 5x makes negative 5x. And negative 1 times negative 1 makes positive 1. Now you can also just think about changing all of these signs. That's effectively all that's happened there. You can also kind of make a pit stop and find like terms and say 4x squared minus 7x squared. 9x minus positive 5x. That can sometimes lead to sign errors, so just be careful. I like to do it this way so that way I know that I've taken care of that subtraction. Then it comes down to identifying those like terms again. Again, if you don't have colors, I'm just going to use straight lines for my x squared terms. I'll use a squiggle for my x terms, and I'll use dots for my constant terms. All right, so now we're ready to combine just the way it says. It seems weird because it does say that we're doing subtraction, but my first operation here is actually to add. We are technically subtracting negative 7, which is going to work like addition. So 4x squared plus 7x squared makes 11x squared. 9x minus 5x will make 4x. Because that's positive, that dictates that sign in the middle. Negative 7 plus 1 makes negative 6. And I have no more like terms to combine, so that makes my final answer. Now the other way that Delta Math shows you these style of problems, they change the directions just a little bit. So on this one, it says to find the sum. Now what we have to remember is that sum means to add. So we're going to take these two polynomials. We have to kind of write our own problem, and then we're going to be adding. So we'll have 2x squared minus 8x minus 6. Sum tells me I'm going to add those two things. plus that other polynomial, 9x squared minus 8. So if we think back to our first example, we're going to just drop those parentheses and rewrite. And then combine like terms. So I have 2x squared plus 9x squared, which will make 7x squared. Oops, sorry, 11x squared. Negative 8x is the only x term, so it just comes down. There's nothing to combine it with. And negative 6 minus 8 makes negative 14. No more like terms, so that makes our final answer. On our last example, it says to subtract this first polynomial from the second polynomial. This can be a little bit more confusing. So first, subtract, that's the easy part. That's where it just means minus. We're going to end up subtracting one thing from the other. This part is going to go second. This part is what actually goes first. It's because of the way that they write it. We have this part, it's being subtracted. This is being subtracted from this. So it means we started with this and we're taking this from it. So when I write it, I want to make sure I put the back part first, then my subtraction sign, and then the first part. That order matters. All right, similar to our other subtraction example, I'm going to bring down the first polynomial. The second polynomial has that negative one that we're going to distribute. So we'll have negative 3x minus 9, just changing the signs. So it looks like 5x squared is the only x squared term. Negative 7x minus 3x will make negative 10x. And negative 9 is the only plain number, making that my final answer.